All right, let's go ahead and talk about blocking versus non-blocking and timeouts. Now, timeouts will handle blocking code that's running too long, or, well, any asynchronous code in our case that's running too long. So what is blocking code first? Now, you're probably very familiar with blocking code. It's whenever you run a block of code, it prevents you from running that next thing, right? Until it's finished running. So this print hello world or hello word is not going to run until this cell finishes. Now that's actually really useful, right? We actually want that function to finish before the next one runs. And with synchronous code, it's really easy to handle those things. Asynchronous in Jupyter, we can actually have blocking code as well by calling this await method here. So using await on a function blocks the code from running to the next thing, right? So it does the exact same thing as that synchronous code. But what starts to happen when we do things like this, we start to get non-blocking code. We start to get code that's going to be running regardless of, how long it's taking or the fact that everything else is running. So this example from before, all of these sleeper functions are running when you run this a run. It just doesn't necessarily show up. That's why it popped up really fast. So what we can do is actually have a timeout for something like this. But before we get there, what I want to do is actually talk about how to write non-blocking code inside of Jupyter itself. And that is by using the loop that Jupyter has built in. So Jupyter uses async IO, and it has what's called an event loop. So you're going to see this a lot, this get event loop. One of the things that you'll also see in some code, like especially projects that aren't inside of Jupyter, is not get event loop, but new event loop. You'll also see something like async io.run. Okay, so I'll explain these things as we go forward because some of them we'll use. But the main thing here is loop. We can actually use that to write non-blocking code that will still absolutely run whatever it is that we need to run. So I can literally say loop.create_task. Remember that create task method from before? If I scroll up here, that's this right here. It's identical on how it actually functions. So we can create a task that's going to be non-blocking now, like this a sleeper method. And of course, we still want to run the coroutine, so I have to initialize the function and then pass something in here. But now if I want to go ahead and print something after that, I can just run it. And there we go. So that's still running that a sleeper function. It's not going to stop running it. It's going to run for 123 seconds. That's a long time. But the nice thing is it does two things for me. One, it actually gives me a task that's pending. And two, it's not blocking anymore. So this is really important in Jupyter files especially, is it's asynchronous code that's running concurrently, right? It's going back and forth. But the other part is that I can still continue to use my Jupyter Notebook. I just really can't use the result of whatever that function is until that function's created and finished, which actually probably makes sense. Okay, so what I want to do then is I want to actually take a look at how to handle timing this thing out, right? So if this is running way too long, like 123 seconds is a long time. It's 2 minutes. It's going to be more than I'm talking probably. But the fact that it's so long means that I also have another feature that is called wait. Okay, so wait will return back done and pending. Okay, so let's go ahead and actually call this. Naturally, we actually don't need the loop now. We can just use async IO. And again, we're calling a coroutine, so we need to await it. Right, it's an asynchronous method here. So we want to wait until this is finished. Now I can actually add in a timeout here of, let's say, for instance, 2 seconds. And what's cool about this is now I can actually see what's done and pending. Or not pretending, but pending. Okay, so let's actually add one other aspect to this. Oops, this should be a list of items here. So I have 2 of those, 2 coroutines there. And so the first one is just going to be 1 second long. The second one is still that enormously long one. Okay, so if I run this, what I'll get after 2 seconds is I'll have one that's done and then one that's actually pending. Pretty cool, huh? So this pending one is still pending. It hasn't been run. It hasn't been finished because we timed it out. So that will pinned indefinitely until we actually await it again. So we can await it again by running it in here. So we can call it in here. Okay. So that will now run for that. It's going to wait for that to finish. And again, it will give me two results. One that's done and one that's pending. Okay, so I'm going to let that keep running. That might run too long here, but what I will do is one other kind of timeout, which is wait for. So I'll go ahead and copy this, and it's simply wait for. And now we just pass in the coroutine that we want. So in my case, a sleeper, and pass in the arguments that we want. So 5, and then I'll go ahead and do timeout equals to, let's say, 3. Okay, so I'll go ahead and run that. In fact, I'll actually interrupt the kernel because I don't want to wait for that pending one any longer. But I do want to run this timeout here. All right, so this is going to time out after 3 seconds, and it actually runs an exception. So that's the difference between these two. This one will return if it's done, and then a pending one, right? So the ones that go beyond what that timeout is go right into pending, that we can do it later. Like maybe at the end of the day or some other time, we actually run that pending task, or we just delete it altogether. Whereas this one will literally time out and run an exception, which we can handle, right? So it's really simple to handle these. We put it into a try block, and then we run the exception of async io.timeout error print task failed. Run that, and then after the timeout, whatever that number is, we get that exception. Okay, so that's just a very simple and easy way to handle that timeout. Now, again, why is it that we need a timeout at all? Well, it has to do with this, of course, right? So when you're scraping websites, every once in a while, their service might time out. Like their service might time out. So we don't want our function to be waiting for it for that long. The other thing is, what if our database, like we lose connection to our database or something like that? We want to make sure that we can either time out or put tasks to come back later, and thus we need to know about that. And the blocking part is also part of that, right? So typically, if it wasn't asynchronous, blocking would have a timeout feature. You could add in timeouts for the blocking one, a synchronous code. But asynchronous code is a lot harder to figure out where that blocking's happening, where it's stopping, what's failing, all that. So it's really nice to be able to use this wait for method here because we can actually wrap that on anywhere, right? So in our sleep method, we had it here. And I mentioned that perhaps that would be simulating grabbing something. So instead of doing this sleep call, we could literally put the wait for call around that sleep call and run that. Right, so scroll up a little bit. We could put it like that. And that will quite literally wait in the same way. So timeout being, 5 or something, right? That will still execute here. So let's go ahead and try that out. It looks like I might have a task running. Nope, I do not. Oh yes, so sleeper. A sleeper was in there, and then we get this timeout error. So right away we can see some of the benefits of using this timeout, and then of course I could add in a timeout parameter here that would actually put that right in with this a sleeper. Right, so in 4 seconds, boom, it's gone. Oh, I didn't actually update the parameters here, and let's do it into 1 second just to verify that that's working. Very, very quick. Okay, so I'm actually going to leave that in as just the regular sleeper and come down to the bottom and bring that timeout function in here, and we'll call it a sleeper timeout just for your reference. So when you use these things, well, the main thing is if you don't want your program running too long, add in a timeout. So when in doubt, it's often really good to add in these timeouts because your software should actually run really fast. So with a web scraping event, 30 seconds is way too long, right? Intuitively, you might know this. But typically speaking, like when you open a web browser and a web page, if it's taking 30 seconds, if you have decent internet, that's way too long. So that might be a really good timeout to initially have for many of your functions, just to make sure that they're not actually breaking your own system. Like you don't want your Python functions to be running forever, which is definitely a trap you can get caught up with asynchronous software. All right, let's keep going.